If you drop into the Antarctic Ocean, the first thing you notice is that everything is too big. Sea spiders the size of dinner plates. Amphipods as long as your hand. Starfish wider than your chest. Octopuses that barely move but live for years. Jellyfish longer than a bus. Squid heavier than a car. This isn't one strange exception. It's the entire system. And what's unsettling isn't just the size. It's how quiet everything feels. Nothing rushes. Nothing explodes into motion. Nothing seems in a hurry to be alive. To understand why these animals are so large, you have to stop thinking about Antarctica as a place of constant danger and start thinking of it as a place defined by long waiting. That story begins with animals that spend almost nothing just to exist. Antarctic sea spiders look unfinished. Mostly legs, a tiny central body, almost no visible muscle. Some species don't even have a proper body cavity. Their organs extend into their legs. Heart, gut, everything. They don't have lungs. They don't really have gills either. Oxygen simply diffuses straight through their bodies. That only works because Antarctic water is cold, dense, and packed with oxygen. They don't chew food. They pierce soft animals like sponges or anemones and slowly suck nutrients out. Nothing about a sea spider suggests speed, or power, or aggression. In warmer oceans, a body like this wouldn't work. Oxygen isn't dense enough. Diffusion alone can't keep tissues alive. A sea spider this big would suffocate. Here, cold water changes the rules. Being large doesn't make them dangerous. It makes them possible. The question is, how far can that strategy go? In a place where food can vanish for months, survival doesn't belong to the strongest animal. It belongs to whatever can stay alive while doing almost nothing. But that only works if you can survive long gaps between meals. And that's where Antarctica reveals its next solution. Antarctic giant amphipods take waiting and turn it into storage. In most oceans, amphipods are tiny, frantic scavengers. They survive by staying busy, always moving, always feeding. That approach fails here. Some Antarctic amphipods grow to the size of your hand. They live on the seafloor, barely moving for long stretches. When something dies, a fish, a seal, a fragment of whale, amphipods appear quickly. They swarm the carcass. They tear into it. And then, something strange happens. They stop. Their bodies visibly swell as they pack away energy. Then, they retreat back into stillness. They're not searching for the next meal. They're living off the last one. In warmer oceans, stopping like this would be dangerous. Stored energy burns fast. Movement is constant. Here, cold slows digestion, metabolism, and time itself. Waiting becomes cheaper than moving. A big body lets them store food and live off it longer. But Antarctica doesn't just reward animals that wait between meals. It rewards animals that can stretch the act of feeding itself. That's where Antarctic starfish quietly dominate. These starfish are enormous. Thick arms, heavy bodies pressed against the seafloor. They don't move much, and when they do, it's almost painfully slow. Starfish don't eat the way most animals do. When they capture prey, they push their stomach out of their body, wrap it around the animal, and digest it externally. That process can take days. Days where the starfish barely moves. In warmer oceans, that meal wouldn't last. Another predator would steal it, or eat the starfish. Here, competition unfolds on a slower clock. Some Antarctic starfish live for decades. They can survive long periods without eating at all. They regrow lost arms without urgency. Their size gives them surface area, stability, and time. They don't need to finish a meal quickly. They just need to still be there when it's done. And Antarctica pushes this logic even further, beyond feeding, into reproduction itself. Octopuses are usually symbols of speed and intelligence. Curious, restless, always interacting with their environment. In Antarctica, octopuses behave differently. They move carefully. They conserve energy. They behave like animals that understand the cost of motion. And then there's reproduction. Some Antarctic octopus species guard their eggs for years. Not days, not weeks, years. They don't eat during that time. They don't hunt. They barely move. In warm water, this would be impossible. A tropical octopus guards eggs for weeks, then dies. Try waiting years, and you'd starve long before the eggs hatched. Here, cold water slows metabolism to a crawl. Large bodies store enough energy. Predators are rare. The eggs develop slowly, but safely. This isn't intelligence showing off. It's intelligence submitting to the rules of the environment. And Antarctica takes that submission even further, to the point where the animal almost disappears from the process entirely. And once you reach that point, where an animal barely needs to act at all, you start seeing creatures that don't really behave like animals anymore. Antarctic jellyfish don't hunt. They don't search. They don't even seem to decide. They drift. No brain, no heart, no bones. Some are more than 95% water. In Antarctic oceans, some grow incredibly long, trailing tentacles across vast stretches of ocean. Not because they're chasing anything, but because they don't have to. In warmer oceans, jellyfish often have to pulse constantly just to stay fed. Here, they drift. And somehow, that's enough. And if you follow this idea, letting cold, time, and patience shape an animal to its absolute extreme, you end up with something almost mythical. The colossal squid. It's famous for being huge, but that's not the unsettling part. What matters is how long it takes to get that big. Cold Antarctic water slows everything. Growth, metabolism, life itself. Some estimates suggest colossal squid may take decades to reach full size. In warmer oceans, growing slowly gets you eaten. Predators are everywhere. Encounters are constant. Here, encounters are rare. Energy is spent carefully. Nothing is rushed. The squid isn't racing toward adulthood. It's accumulating size over years, maybe decades, in a system that doesn't forgive waste. Size isn't forced, it's earned. Now, step back and look at what each animal has done. The sea spider minimizes the cost of existence. The amphipod turns feasts into long pauses. The starfish stretches feeding across days. The octopus pauses reproduction for years. The jellyfish lets physics hunt. The squid builds a body across decades. Different animals, different life histories, same rule. Antarctica doesn't reward speed. It punishes urgency. We expect harsh environments to produce aggressive, hyper-efficient killers. This one doesn't. It produces systems that are slow, conservative, and hard to starve, built to last rather than dominate. That's why the Antarctic Ocean feels wrong. It breaks our assumptions. Big doesn't mean fast. Big doesn't mean aggressive. Big means stable. And the most unsettling part? The strategies that work best here are almost invisible. They don't fight. They don't rush. They don't announce themselves. They wait. If you only watch what moves fast, you miss what lasts. Here, patience stretches so far, it looks like nothing is happening at all. Giants don't announce themselves here. And while we're busy looking elsewhere, the living world unseen carries on without us.